How to write better prompts, achieve more, pay less, become more effective, and become a better prompt engineer. Today I want to cover with you a few interesting researches and a few interesting GitHub repositories that can help you become a better prompt engineer, develop and build faster. This is a bit of theory. Some people who are not looking to become more advanced might find this boring, but in my opinion, this is a fascinating topic and I wanted to share with you my learnings. I must say that I'm not an expert in this field. I'm still learning. It's very new and this is developing and evolving all the time. But I wanted to create this video in order to share with you again my learnings, and hopefully if I teach, I can also learn faster. So before I share with you a bit more insights, let's show you why this is important. So there recently were published a few researches regarding how prompt engineering can achieve higher efficiency and better, basically outperform. And okay, I will rephrase. How with correct prompt engineering, even GPT 3.5 Turbo can outperform an untuned GPT-4. So this is a blog post from the Autogen website, and you can find it here. Does model and inference parameter matter in LLM applications? So long story short, just by tuning the inference parameters like model, number of responses, temperature, etc., without changing any model weights or prompt, the baseline accuracy of untuned GPT can be improved by 20% in high school math competition problems. So this is very interesting. Just by giving better parameters like the number of response, temperature, etc., you can achieve more out of your LLM. For easy problems, the tuned GPT 3.5 Turbo model vastly outperformed GPT-4 in accuracy, 90% versus 70%. Obviously, it is way more cost efficient because we know that GPT-4 is more expensive. And obviously, that they are saying that Autogen can help with model prep, with model selection, parameter tuning, and cost saving in an LLM application. Long story short, based on this blog post, which you can read more about this, GPT 3.5 is way cheaper. GPT-4 costs 10 times more than GPT 3.5 Turbo. But when setting the correct temperatures, top P, maximum tokens, the correct prompt, and the number of responses to generate, they were able to achieve to make GPT 3.5 outperform GPT-4. And if you don't know what is temperature, okay, I was planning to cover this later, but let's cover this now because I think it makes more sense. So temperature is the parameter that controls the randomness of the output text. A higher temperature means more diversity, but less coherence. We search for the optimal temperature in the range of 0 to 1. So if we set the temperature to 1, it's going to be completely random, and if we set it to 0, it's going to be deterministic. Top P is the parameter that controls the probability mass of the output tokens. Only tokens with a cumulative probability less than or equal to top P are considered. A lower top P means more diversity but less coherence. We search for the optimal top P in the range of 0 to 1. Max token is the maximum tokens that can be generated for the output. N is the number of responses to generate. We search for the optimal N in the range of 1 to 100, and the prompt is the actual prompt that we use. Let's ask it to provide some examples, just so we will clarify this. Can you give some examples for these concepts? By the way, this is the way I usually learn. I just ask, okay. So temperature. If the temperature is set to a low value, the model's response tends to be more predictable and coherent. For instance, if asked about the capital of France, the response will likely be Paris with high confidence. At a high temperature, the model might generate more creative or less expected responses, like discussing lesser-known facts about Paris or drawing analogies to other cities. Top P. With a low top P value, e.g. 0.5, the model chooses from a smaller set of words, leading to a more predictable text. For example, in a sentence about weather, it might stick to common descriptions like sunny or rainy. In contrast, with a high top P allows the model to consider a wider range of words, potentially leading to more varied and less conventional descriptions, like a sky speckled with wispy, I don't even know how to read this word, cirrus clouds. If the max tokens is set to 50, the model generates response up to 50 tokens long. This works well for concise answers or short explanations. If we set to 500, we're going to get a more detailed response suitable for in-depth explanations, stories, or comprehensive analysis. With n set to 1, the model generates a single response to the prompt. This is standard for straightforward questions where one answer suffices. In contrast, if we set the n to 5, the model will generate 5 different responses, offering various perspectives of our solution. This is useful for brainstorming or when multiple viewpoints are desired. The prompt, I'm not going to elaborate about the prompt, but I'm happy that we covered this already. Now, here we find another blog post in the AutoGen blog area in which they discuss the same. A case study using the human eval benchmark shows that an adaptive way of using multiple GPT models can achieve both much higher accuracy and lower inference cost by 80% than using GPT only for coding. So basically what they did, they're saying GPT 3.5 can already solve 40 to 50% of tasks. For this task, if we never use GPT-4, we can save nearly 40 or 50% of the cost. If we use the saved cost to generate more responses with GPT-4 for the remaining unsolved tasks, it is possible to solve some more of them while keeping the costs down. So basically, they are saying that using AutoGen in a smart manner, or in general, prompt engineering, about 50% of problems can be solved by GPT 3.5 Turbo. So using GPT-4 is an overkill if we have any constraints of cost. Another interesting fact or observation, as I said, that it's easier to verify a given solution than finding a correct solution from scratch. So they often strive to provide solutions and then just ask for feedback. So for example, you can generate, let's say I want to do cold outreach at scale. This is what I'm doing. So I scrape the bio of my prospect. Let's say it's a CEO of a company. He lives in New York. He has an e-com store. And instead of just going ahead and generating the personalization with GPT-4, which can be expensive at scale, let's say I want to outreach to 1,000 people daily, what I can do is I can generate the personalized outreach with GPT-4 3.5, which is going to be cheaper. And then with GPT-4, I can create another layer of validation. And this is, instead of creating the whole thing from scratch, GPT-4, which is the more expensive model, is just going to verify the solutions that was provided by GPT 3.5. So this is also an interesting angle that you can use in order to reduce cost, also increase speed, although I don't think speed is such a crucial aspect when doing the type of stuff that I'm discussing. But still, it's an interesting approach. And here they are also sharing different examples of how they used GPT 3.5 with 7 different responses and how it was able to produce better results than what GPT-4 created with only one iteration. So this is very interesting. And again, I just want to share with you why this is important and why this shouldn't be overlooked. If you are anything like me, I basically, most of the time, I just ignore these parameters and I was just asking GPT-4 to spit out the content, and I didn't really fine tune. I just changed the prompt, and now I see why this is so important. The next thing I want to share with you, and again, this is also another example. This is the prompt-based library by the Microsoft team, and they discuss all things prompt engineering. And basically, what they want, I wanted to share with you here. Obviously, I will share all the resources in the show notes, and I suggest that you read them and take a look. But what is interesting here is using this type of fine-tuning the prompt achieved way better results. As you can see, med prompt is the type of prompt adjusting. Okay, so I will explain. Prompt based is an evolving collection of resources, best practices, and example of scripts for eliciting the best performance from foundation models like GPT-4. We currently host scripts demonstrating med-prompt methodology, which is including examples of how we further extend this collection of prompting techniques. So basically, this type of prompting, GPT-4 med-prompt, you can see it how it outperformed the simple prompts. Just look at simple prompt, such a small area with regards to performance, in opposing to this huge area of GPT-4 with the med prompt. So just by providing the correct prompt, look how much better you can produce so much better performance. And here they are explaining a few mechanisms of why and how they create better results. So one is a dynamic few shots, which we will cover later. Okay, maybe we cover this now. I plan to cover it later, but I think it makes more sense now. So few shot learning is providing several examples of the task and response to a foundation model, which enables models quickly to adapt to a specific domain and learn to follow the task format. I can give you an example that I had here. Okay. So basically, I asked ChatGPT to explain this before, just so I'll be able to share it with you. So this is about teaching a computer model how to do a specific task by showing it a few examples first. Normally, these examples are the same for every task, but sometimes they might not fit to all solutions. So basically, you just give a few examples, and instead of getting the first prompt, you take a few of them. And basically, you teach the model what you're expecting. The next one is self-generating chain of thought. So this relates to making the computer models think step by step. So like a human would when solving a problem, usually experts would write these step-by-step examples for the model, but instead of using experts, they ask GPT-4 to write its own examples. This helps the model to reason through problems more effectively and reduces the chance of making mistakes based on wrong examples. So there is an example here. Basically, once you tell the model, let's think by step, it's going to break down everything. And when it breaks down everything, the output is more coherent and it doesn't hallucinate. So this is an interesting thing as well. And the last thing is majority vote ensembling, which this technique is like getting several opinions and picking the most common ones as the best answer. Pretty straightforward. I'm wondering, should I explain this to you as well? Okay, let's cover this. No, we will skip this. This is a way of testing different LLMs. I don't want to bombard with too much theory, although this is only theory. But let's move on to some practicalities. So, practicalities. This is from the Microsoft website. I will share the link in the show notes, obviously. And this is just an intro to prompt engineering, and I find it very useful. Okay, so first we cover instructions. Instructions are likely the most commonly used prompt component. Instructions are simply instructions. While simple in complex in concept, they can be complex in practice. So this is an instructions, simple instructions, complex instructions. This is another form of complex instructions. Now, primary content refers to some sort of text that is being processed or transformed by the model. Primary content is typically used in conjunction with instructions. A simple example would be language translation. In the example below, the English text would be considered the primary content, while translated to French is the instructions. So far, so good, obvious. Can you please tell me how to get to the museum? Translate to French. We have this example as well. Summarize the previous text. Create a TLDR, etc. GPT models can also handle primary content that is structured. In the example below, it just has like this. Just an example of the fact that GPT model can also handle this type of content. Now, successful prompts often rely on the practice of one shot, like we said before, or few shot learning. This refers to the inclusion of one or more examples of the desired behavior of the model, typically by including input and output pairs. This is not learning in the sense that the model is permanently changed, but rather that the examples better condition the model to respond as desired for only the current inference. The use of prompt with no examples is sometimes referred to zero-shot learning. Note that with chat completion, API few shots learning examples are typically added to the message array, blah, blah, blah. Okay, now, great example. So zero shot. Headline coach, confident injury, won't derail Warriors. Topic, there is no topic. The coach is confident that the injury won't derail, and this is the completion. Now, few shots, you can see they give an example, and then you are expecting from the model to complete. So here's a better example. Here it was zero shot, no examples. Now an example. Headline, Twins Korea to use opt-out test free agency. Topic, baseball. Now headline, Qatar World Cup to have zones for sobering up. Topic, soccer. Headline, Yates, fantasy football intel for week 6. Topic, football. Now, coach, confident injury won't derail Warriors. Topic, basketball. So you can see that here, because this is a few shot prompts, and we gave examples, it knew how to follow this pattern and just say basketball. While here, it was the same prompt, this one and this one. But here, it didn't know to follow this pattern, so it just wrote this completion. Now, Q acts as a jumpstart for the output of the model, helping to direct the model to desired output. Okay, so here's the number of Qs. Performance reviews are a component of our performance and development approach at blah, blah, blah. Summarize the above email message. And here's the completion. The purpose of this email is to inform employees of recent changes to the performance review experience, which is part of our performance development and approach. The change include an improved, etc., etc. Now here, they give a cue. Performance reviews are a core component of our performance and development approach at Contoso. Summarize the above, and the email message is the takeaway. So you can see here, because we have a cue, it is more precise to what they are expecting. Now, they have more cues, so email message and key points in bullets. So, and the completion is Contoso is introducing changes to the performance review experience based on feedback form from employees. Now it completed with bullets. So you see, once you give more cues, the completion is going to be more precise based on what you expect. Supporting content is another aspect, is information that the model can utilize to influence the output in some way. It differs from primary content in that it is not the main target of the task, but it typically used along the primary content. Common examples, which include contextual information such as the current date, the name of the user, preferences, and so on. The example below uses supporting content to help organize a set of planned workshops for the user. Without the supporting important topics, the model simply lists off workshops. When informed of the important topics, the model is able to accurately group the meetings. So here's, without the supporting content, workshop list, title, description, planning workshop kickoff. Please join us to kick off our workshop, hear from our leaders about cross-group priorities and learning from the year ahead. And you can see the completion, planning. While here we have the important topics, so it grouped the workshop by the important topic. So workshop list, you can see the difference. Prompt engineering, search GPT models. So here it is already more structured based on these topics. So best practices. Be specific. Leave as little to interpretation as possible. Restrict the operational space. So this reminds me of one time that I had a guest on my podcast, and he said, we discussed how to handle employees and how to give guidance. So we said that instructions shouldn't be very well crafted or very clear, which is what I initially thought. He said good instructions leave zero room for error. And it might sound the same, but it actually makes a huge difference. Whenever you write a SOP or if you write a prompt, you should ask yourself, are these instructions very clear, which is good, or are these instructions leave zero room for error, which is perfect and what you should strive for? So be specific. This is one thing. Be descriptive. You should use analogies, provide context, provide examples before you get started. Just that the model will know what you expect. And I know it might seem as if it makes the generation of text and code slower, but it actually makes you more precise and move faster. The next best practice is double down. Sometimes you may need to repeat yourself to the model. This is a very interesting part. Give instructions before and after your primary content. Sometimes if you say to the model, summarize the paragraph below, and then you share a paragraph, it's going to produce worse results than if you say, this is a paragraph, summarize the paragraph above. So it matters. Oh, you see here, order matters. The order in which you present information to the model may impact the output. Whether you put instructions before your content or after can make a difference in output. Even the order of few short examples can matter. This is referred to recency bias. The model gives more weight to what he saw lately, so order matters. Another interesting thing with regards to prompting is give the model an out. So it can sometimes be helpful to give the model an alternative path if it is unable to complete the assigned task. For example, when asking a question over a piece of text, you might include something like response was not found if the answer is not present. Instead of the model hallucinating and just generating garbage, you can always give him a way out. Tell him, if you're not sure, respond with, I'm not sure. Now, space efficiency is not so crucial. I'm going to skip this, and we're going to move to this blog. I know it seems very long, and most of you probably already dropped off. Only those that are really interested in this probably sticked. But here's like a more advanced prompt engineering techniques. I want to move fast. So a few short learning we already covered. Start with clear instructions. This is the system message. So you give context to the model on what you are expecting. You're an AI assistant that helps people find information. Now, your task is to verify the statement. Several sources mention a chance of another large eruption is supported by a specific word from the following set of snippets. These things are very important as well because syntax matters a lot. You see, they have the separation using this, and then they ask, is the statement several sources mention a chance of? It doesn't really matter, to be honest. I mean, it doesn't matter. I don't want to cover the whole example, but the fact is that syntax matters. And in this case, if you provide the system message before, and then you write a big chunk of text, but you separate the text with this, and you make the text more readable, the likelihood of getting better output increases. The next thing is repeating instructions at the end. We already discussed this. The next thing is priming the output. So this refers to including a few words or phrases at the end of the prompt to obtain a model response that follows the desired form. For example, using a cue such as here's a bulleted list of key points, and then you make sure that the output is formatted in a bulleted points. Add clear syntax. So as I said, these separators. Break the task down. So this is very also valuable. Large language models often perform better if the task is broken down into smaller steps. For example, in the search query prompt referenced earlier, the prompt can be restructured so the model is first instructed to extract relevant facts and then instructed to generate search queries that can be used to verify those facts. So basically, just breaking down what you expect will produce better output. This is a bit too technical. Let's move. Chain of thought prompting. So this is a variation on the break down the task technique. Instead of splitting a task into smaller steps, in this approach, the model response is instructed to proceed step by step and presents all the steps involved. Doing so reduces the possibility of inaccuracy of outcomes and makes assessing the model response easier. So we give the system message. You are an AI assistant that helps people find information. Now, the actual prompt is, who was the most decorated maximum medals individual athlete in the Olympic Games that were held at Sydney? Take a step-by-step approach in your response, cite sources, and give reasoning before sharing final answer in the below format. Answer is name. So you can see the response was step 1, determine the year of the Sydney Olympic Games. Find a list of individual athletes who won multiple medals. And then it gave the response. The next alternative is specifying the output structure, which we discussed this. You can also give output format as a JSON. Now, temperature and top P's parameters is what I wanted to discuss before. We will skip this now. Providing grounding context. One of the most effective ways to provide reliable answer is to give the model data to draw its responses from, grounding data. And we will discuss this in a different video, which I'm planning to do. If your use case relies on up-to-date, reliable information and is not purely creative a scenario, we strongly recommend providing grounding data. In general, the closer you can get your source material to the final form of the answer you want, the less work the model needs to do, which means there is less opportunity for error. So basically, if you want to learn how to create a new GitHub repository, like we did in the video a few days ago, it's best if you upload the whole GitHub repository and README file to the model as a file, as a knowledge base. So basically, this part of the of the instructions, it just discusses the fact that if you share a knowledge base, you will get better results. And now moving forward, we can discuss guidance. Guidance is a way to control large language models, and it just shows you how different prompts can provide different output. So basically, here you tell the model what you expect. So do you want a joke or a poem? So the model says, I'll give you a poem. Now, if you have constraint generations which selects regular expressions and context-free grammars, you basically give the model two alternatives. Do you want a joke or a poem? And then select between joke or poem. So the model only needs to select between the alternatives that you provided. Another alternative is rich templates with strings. So you give here, do you want a joke or a poem? Then select joke or poem. And then here is one liner. So you tell it exactly what you expect. This is a bit more technical. I'm just showing you like very fast. Stateful control plus generation makes it easy to interleave prompting, logic generation, no need for intermediate parsers. I'm wondering if we should keep on covering this. Basically, this library allows you to, like its name, guide the model regarding what you expect. This is quite technical, a bit of, only if you need production, I think, if you need production level and very precise stuff, this makes a lot of sense. And another last library that I wanted to share with you, and this is how we are going to conclude our video today about prompting, is the prompt tool, which is a GitHub repository that allows you to test your prompts. Basically, you can insert different prompts and it will tell you which prompts are better than others. And it can generate these comparisons. You can have the prompts tested in different LLMs, but let me just show you an example. So we have name Bob, and the question is, can you help me find a specific product on your website? And this is one prompt, and this is the other prompt. And this is the table of what was produced. So this is the prompt. You're an e-commerce chat assistant for a shoe company. Answer this user's question, name and the question. This is the name and this is the question. And this is a different prompt. So you're a smart, bubbly customer service rep for a shoe company. Answer these user questions concisely. So you see the difference between both of these. And now you can see what was the response. In this case, of course, Bob, I'd be happy to assist you. Could you please provide me with more details about the specific product you're looking for? In this case is, absolutely, Bob. I'd be happy to assist you in finding a specific product on your website. So this is more concise, you see, in opposing to this. Next one is the question to Jane's question was, do you have any promotions or discounts currently available? In this case, the output mentions as an AI. It doesn't realize that it's not an AI. It's supposed to, as we said, the prompt was, you're an e-commerce chat assistant. In this case, the prompt said, you're a smart, bubbly customer service rep for a shoe company. And here are the responses. As an AI, I don't have real-time access to current promotions or discounts. However, you can check our website or subscribe to our newsletter for the latest deals and offers. Blah, blah, blah. And this was the response with this prompt. So, yes, Jane, we currently have a promotion where you can get 20% off on your second pair of shoes. You see the difference. Now here, Another example, can you check the availability of a product at a specific store location? In this case, the output mentions as an online chat assistant, while in this case, it responded, I'm sorry for the inconvenience, but as an online customer service representative, I don't have real-time access to this. And so on and so on. So basically, this tool allows you to test different prompts for your production level, and you should test your prompts because if you have little or zero room for error, your prompt should be precise and you should be able to reproduce the output in different scenarios. So this is why this tool is so important. Again, this is only if you're really, not really technical, but if you really need to be precise and you have to get your prompts perfect, I suggest checking out this tool. Oops, that was long. Let's just start summarizing. A lot of things that we discussed might seem a bit technical, but I think it's very important to have this foundation of knowledge regarding prompt engineering. I don't think, although I don't like to predict, I don't think that prompt engineering will become irrelevant. Some people say that soon enough, because of the AGI and agents will be so smart, we won't even need to prompt. I don't think so. I still think that the fundamentals will be important. Mostly what we covered at the beginning, like what is zero shot, the importance of the temperature, etc. If you're interested in improving your prompts, I think it makes a lot of sense to have the system, the system message, and having context and providing like examples of how you expect the output. These are all things that you can start using today and implement, and I think they can improve the way of production and your effectiveness. The things that we discuss later regarding guidance and prompt flow, these are a bit more technical, only if you're developing something with AI and really need it to be precise and perfect, you should dive into this. I'm not sure that I'm going to dive into them at the moment because they don't match my own use cases. But still, it's I want to keep being updated on what's going on and learn about the tools, and this is why I shared them with you. I hope you enjoyed this video. I'm curious to hear your feedback about it. Please leave a comment in the comment section and let me know, was it too long? Did I cover too much theory? What are your initial thoughts? And based on this, we will iterate and keep learning together. Until next time, if you enjoyed the video, obviously, please subscribe, leave a like, and keep on automating. Take care, guys, and best of luck.